I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover the deprecated functions incorporate scan activity. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally, that you've completed the requirements taxonomy, security requirements, secure design principles, apply secure design, secure settings, deprecated functions overview, and deprecated functions identify functions trainings. This training will cover deprecated functions scan incorporation. Before getting into scan incorporation, let's briefly review where it fits in the overall deprecated functions process. Here's the deprecated functions process, which we previously covered in the deprecated functions overview training. Our focus on this training will be on the second activity, that of scan incorporation. In the incorporate scan activity, the DevOps SME takes the deprecated function list, the element to be scanned, and the build file, and makes the changes necessary to the build file to enable scanning. This results in an updated build file. If the build settings are changed, an updated build settings report is generated. There are a few important points to consider when it comes to how the scan is actually incorporated for a particular element. The first is the embodiment of the deprecated function information. In the previous training on function identification, this information was compiled using the AVCDL deprecated functions catalog template. It was noted that the information could be embodied as a database. So keep in mind that the source of the information that the DevOps SME has to work with is not guaranteed to have a particular embodiment. Second, when updating the build file, you're going to do so based on a particular element, not globally. This avoids excessive scanning in areas which are not of interest. Third, as with all build process changes, it's important to consider the impact that the addition of the deprecated function scanning has on the build process itself. Although it's not anticipated that the scan is going to be time and resource intensive, at scale, it may well be. And so it's important to pre-flight the scan to determine what impact it has and adjust the build timings accordingly. Treatment of the updated build settings report are covered in the secure settings process, documented in the secure settings document, AVCDL secondary document, with additional detail provided in the secure settings apply options procedure, AVCDL tertiary document, and their associated trainings. Now let's consider the scanning tool itself. There's no single way that deprecated function scanning can be accomplished. If you have a static analyzer or other tool capable of ingesting the list of functions and applying it against a specific element, that's great. If you write a shell script that performs the same function, that works too. It's all a matter of what the organization has made available to accomplish this task. The scanning tool should be able to ingest the deprecated functions information generated in the identify functions activity, avoid foreseeable false positive scenarios such as names and strings and comments, or those which are class member functions, and of course the tool needs to be able to output issues. The output should include the location of the deprecated function, and if the tool is capable of doing so, it should also provide a description with the reason for deprecation, the recommended replacement, and a reference to the source of the deprecation. Now let's have a look at some typical data that we'd be using to perform the scan in order to motivate the scan incorporation activity. We'll be using the deprecated functions C++ on Linux workbook based on the AVCDL template that we've covered in the previous training on identifying functions. As mentioned, we'll be using the C++ on Linux deprecated functions workbook that was used in the identify functions training. Here's the deprecated formatting function sheet from that workbook. We have an ID, the function itself, the header it comes from, the reason for the deprecation, a suggested replacement, and a notes column. The notes column provides pointers back to the references, which we see here, and those references include the name of the reference, its description, and where it can be found. When performing the scanning operation, minimally, we require the deprecated function. We can see from this list that this is a family of functions. their names are virtually identical. It's important, if you're approaching this using manual scripting, that you take this into consideration, because the last thing you want is to see, say, scanf in DFF00 show up as being flagged for all of the scanf family of functions. Similarly with sprintf and snprintf. If you don't consider this substring effect, then you're going to have an unwieldy number of false positives. Beyond identifying the deprecated function, it would be nice to know why the function is deprecated and what the suggested replacement is. One could get all sorts of fancy in terms of reporting the suggested replacements when you have a particular version of the language that you're considering. In our example, we have replacements which require C++20, C++17, and C++11. That implies much more sophisticated tooling in order to only report the applicable replacements. Additionally, having a reference to the particular source is also useful. As we can see here, the location information provided are in the form of URLs. If that's the case for all of the ones that you have, then the tool can go to the notes, look up the particular entry, and emit the location into output. That covers deprecated scan incorporation. Let's review some of the high points. First, select the scanner. It may be an existing tool, such as a static analyzer or other off-the-shelf utility. Alternately, you can create a custom script to perform this activity. Next, consider false positive scenarios. This is especially important if you create a custom script. When using a pre-existing scanner, make sure that it accurately identifies the deprecated functions uniquely. Next, apply the secure settings process if that's appropriate. Remember that it's this process which generates the updated build settings report. Finally, whenever the build is being augmented, you need to verify that the build will still work within the parameters of the CI/CD system. The materials that were used to cover this example are in the location shown here. It's important to note that the workbook includes all of the sheets covered in this training. For additional information and to get a more in-depth set of references, the Deprecated Functions Incorporate Scan Procedure Tertiary document and the Secure Settings Apply Options Procedure Tertiary document are both available in the AVCDL GitHub repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. With this training complete, if you've completed the other trainings covering the deprecated functions process activities, you can proceed to the other trainings at this level. These include code reuse and secure coding. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation source material will be provided on the AVCDL GitHub repository.